My name is Chris Troutner, and I gave this presentation at the BCH 2022 conference in St. Kitts in November of 22. I only had 15 minutes to present at that meeting, and so this video is a longer version of that same presentation. The intended target audience is Bitcoin Cash developers, entrepreneurs, and CTOs, people in a technical management role. And the title of the talk is Reducing Bitcoin Cash Infrastructure Costs with IPFS, or how the PSF reduced their costs by 90%, and you can too. If you want to take a screenshot of this picture of that QR code, you can scan that and it will take you to a GitHub gist where I have links to resources I talk about in this presentation if you want to dig a little deeper. Again, my name's Chris Troutner. You can find me at Chris Troutner on Twitter and Telegram. So first of all, what is the PSF? That's the Permissionless Software Foundation. We are a consortium of JavaScript developers and entrepreneurs who are interested in tokens and cryptocurrencies. Our mission is to make it easy for individuals to protect their privacy, circumvent censorship, and engage in economic activity. And then IPFS was in the title for people who are unfamiliar with that. IPFS is the Interplanetary File System, and it's not a blockchain or a cryptocurrency. Many people assume that it is because it's so closely associated with cryptocurrencies, but it's not. What it actually is a substitute for the HTTP protocol. So you'll have seen that in the URL bar of your web browser. That's what lets web browsers, or lets the web browser communicate with a server. So IPFS actually replaces that. But for the sake of this presentation, the main feature I want to focus on is this technology called PubSub, which is short for Publish Subscribe. And what it does is it lets IPFS nodes form on-the-fly mesh networks and communicate with one another. And that's the main technology that we leverage in order to reduce our infrastructure costs. So, software stacks are a useful tool for engineers to help focus discussion and particularly for debugging and containing issues within a complex system, which most software systems are. And in this presentation, we're going to use the stack to describe how a phone ultimately talks to the blockchain. So here's an example of what I mean by a software stack. This is sort of the classic stack that people refer to on this subject. This is the 7 layers of the OSI model. This 7-layer stack describes how the internet works at a technical layer. And so when there's network issues, engineers use this to discuss what layer of the stack is where the problem exists. So here's another example of a stack. This is the mean stack. If you're a JavaScript developer, you've probably run across this. And it basically describes one way of building a JavaScript application with a front end and a back end, running JavaScript on both, and then having it talk to a database ultimately. So in this presentation, I want to focus on the cache stack, and you can find more information about this at cachestack.info. And this comes, it's grounded very much in the Web 2.0 paradigm. And it basically, as I said, describes how to build a Bitcoin Cash app from the context of Web 2, which is where you have a client, which is typically a cell phone that has limited compute and limited bandwidth and power considerations. That is trying to talk to and leverage a back-end server that has more compute and more bandwidth to do something valuable and useful. And I typically break it up here in the cache stack into these 5 layers. There's the application, which is the actual web app or Android app or iPhone app that the user sees and has buttons that they click on. There's usually an integration library that turns those button clicks into some specific thing, like sending a Bitcoin Cash transaction. And then that front end talks to a back end over an API layer. So this might be a REST API, gRPC, GraphQL. These are all APIs. And so there's an API layer, and then in in Bitcoin Cash and cryptocurrency applications, there's typically an indexer layer. So this would be like Fulcrum, which indexes UTXOs and addresses and transaction histories, and other indexers like the SLP indexer, or if you've ever used Memo.cash, they have their own indexer. These indexers, they all crawl the blockchain and extract data and make sense of it for some application-specific purpose. And then ultimately at the bottom of the stack is the full node. That's the thing that's actually broadcasting transactions and containing the actual blockchain data. So this is the Web 2 cash stack, these 5 layers. So that cash stack, I should go back. The cash stack was originally developed in 2018 when I worked at Bitcoin.com. This is how my team communicated the software we were building and how we addressed issues. And it's evolved over the years. And this is a simple cost breakdown of one instance of a cash stack. And I want to just draw your attention to the lower right corner, the $50 per month. This is based on Hetzner, which is a very competitive, low-price, mainstream infrastructure provider. So some of their competitors might be DigitalOcean or Vultr or Linode or AWS. These are all, I would put them all in the same bucket of infrastructure service providers. And I've just personally found that Hetzner is usually the least expensive of all of them. And so that's what I wanted to use. So any of those others, this number is going to be bigger than what it is here. And so this one instance of the cash stack can service between 4 to 5 million requests per day, or about 45 to 60 API calls per second, and costs about $50 per month to operate in the cloud. And that doesn't seem like a lot. In fact, it probably sounds really good, but I'll get to some of the empirical evidence that shows that this is actually prohibitively high for a lot of use cases. So in pursuit of getting down to that goal, let's talk about who uses infrastructure. And over the years, as I've talked to businesses and users, I can pretty much put everyone into one of these 4 buckets, and I'll go into detail on each of these in a minute. But there's the casual user, the motivated user, exchanges and established companies, and hobby developers. So first, let's talk about this user spectrum, and that's how I visualize this as a spectrum. So on one end of the spectrum, there are casual users, and they're familiar with installing a phone or app or visiting a web page, but they don't really have any significant technical knowledge. In this case, Web 2.0 is established and proven. The latency and connectivity issues of decentralized tech is usually not appropriate for the casual users. They have a very short attention span and low tolerance for latency and bugs. And they're, in general, not willing to pay money for a service. They might be willing to sign up for an account, but most would prefer not to. So this is the typical American user. And then on the other end of the spectrum are motivated users. They probably live in a country or they're working within a company that is actively trying to prevent them from accessing the blockchain. These users want to circumvent this censorship, and so they're willing to jump through more hoops than the casual user is. But like the casual user, they're also not willing to pay money for service. They'd also might be willing to sign up for an account, but would prefer not to. So both users have that trait in common, and this would be typified by a user in probably Argentina or Venezuela, where everyone knows and accepts that they cannot rely on the government's money system, and so they have to, in order to feed themselves and just do the basic daily needs, they have to find another system to use, and they've gravitated towards blockchain. So again, this is a spectrum, so I'm talking about the 2 extremes, the 2 ends of the spectrum. Most people are going to be somewhere in the middle. And then those other 2 categories form a separate spectrum I call the developer spectrum. And so on one end of the spectrum is exchanges or established companies, and these are typified by how much they have money to spend on infrastructure, and usually they need that isolated infrastructure. They don't want to share it with another third party or another competitor. They want their own isolated infrastructure, and they need that high-speed cloud infrastructure that Web 2.0 really accelerates at, and it's been established to do so. And then at the other end of the spectrum is what I would say hobby developers. So they don't have a lot of money to spend on infrastructure, and they may or may not have their own full node or other back-end infrastructure. They may or may not know how to run it, or if they do, they may or may not have the money for the actual computer and hardware to build it and run it. But this particular category of developers is really important to support because this is where a lot of the innovation comes from. A lot of the new ideas, particularly the really impactful ones, tend to come from this type of developer. And so they're really important to support for that reason. So again, this is a spectrum. I'm talking about the two extreme ends of the spectrum, and most people are going to find themselves somewhere in the middle. This is how I like to visualize that spectrum. So use the use that long line as your foundation. And so above that line, on either end, I have hobby developers on the left and exchange or established companies on the right. And so as you move away from the hobby developer to the established company, the project has more funding to pay for infrastructure. But then as you move to the left towards the hobby developer, the demand for lower infrastructure costs increases. And then below the line, I have the user spectrum, where casual users are on the right, motivated users are on the left. As you move to the left, the users become more motivated. And so the goal here is to push the edges of the spectrum out, not necessarily to be on one end or the other. By pushing the edges of the spectrum to even more motivated users, lowering the infrastructure costs for even more hobby developers, we increase the network effects of Bitcoin Cash. And as we push it out to the right, so that we bring in more established companies and more exchanges, and we make it available to more casual users, we're increasing our network effects. And so the goal is not to be on the spectrum. Well, the goal is to be on the spectrum, but the goal is not necessarily to be in any position on the spectrum. The goal as a community is really to push the edges and make the spectrum bigger. So let me talk about the PSF and our particular goals given this understanding of the users of infrastructure. Our goals were really to reduce the cost of cloud infrastructure and our reliance on big tech, to get away from those established cloud providers, because collectively we believe that there is a battle coming, that there will be a purge where big tech will try to pick and choose winners, or and at some level censor blockchain technology. They'll be deputized by the states to do that. Another goal was to increase back-end redundancies, which is another way of saying decentralizing. But really, I like the word redundancies because the goal really was to make redundant back-ends that if one failed, it's not a big deal. People can just naturally and easily switch to another redundant back-end. And also to increase resources available to those hobby developers that I talked to. Those are particularly of interest to our community, the Permissionless Software Foundation. And there is also some empirical data that's worth talking about that sort of shapes the context for all of this, is that home cloud hosting is becoming more feasible every day. Hardware costs are continuing to decrease, home bandwidth, internet speed is continuing to increase, and so those two things together makes home cloud hosting a much more practical solution than it was in the past. And it's becoming more of a practical solution as we go into the future. And also just, again, from empirically talking to members of the PSF, many more of the members were willing to spend $400 on a desktop and then watch videos and learn how to set it up than they were willing to spend $50 a month on cloud infrastructure. So some people might look at that $50 fee and say, oh, well, that's nothing. Like let's move forward with that. Why do we need anything else? Well, that idea doesn't match the reality on the ground. The reality on the ground is that even $10 a month is too much for a lot of developers that I've talked to, particularly in developing countries, and also within developed countries. Developers are much more willing to just drop $400 one time, and they hate the idea of a monthly cost. So this is what we're calling the Web 3 cache stack. So it's the same Web 2 with one extra layer in the middle that is IPFS, the Interplanetary File System. And then that layer, we can break it out, and it's actually 3 distinct pieces of software, because it's an integration layer. So there's a front end component to it and a back end component to it, and then in the middle is the circuit relay. And let me talk about the circuit relay, because this is really the key. This is the magic sauce that was allowed us to significantly reduce our infrastructure costs and improve our decentralization and improve our censorship resistance. This is not unique to IPFS, but I just absolutely love the way they've implemented it. The idea behind a circuit relay is 2 nodes on the network might be blocked by firewalls, and they can't talk to one another directly. But if they can both talk to a third party on the internet, then that third party, that node, can act as a relay and relay communications between the two. So it's a pretty simple concept. The circuit relay lets IPFS nodes talk to one another that normally would be blocked by firewalls. And the real magic of this is that this has always been possible, but it required a network engineer who knew how the internet works at a very deep level, knows how to configure routes and firewalls, and set up port forwarding, and be able to debug all this stuff when it goes wrong. And that is beyond the capability of most normal people. So what this has broken that all down into software. So that expert engineer is no longer needed. He goes away, and the software just automatically makes this all work as long as this circuit relay exists out there on the internet. And so this is ultimately what we're trying to achieve. Is we have an app on a phone that has low bandwidth, low compute, and power constraints, and we're trying to get it to find and connect to a local backend that is as physically close to it as possible, and then pipe that data over the IPFS network to one of many backends. And by doing this, if one backend is not available, it's not a big deal. The user's app can detect it and say, hey, here's a list of alternative backends, select one, let's give that a go, and if not, we'll try it again until it works. And so let's compare our cost here with the Web 2 and the Web 3. In the Web 2, as I covered, there was a $50 monthly cost and no setup cost. And again, this is just pure overhead. This isn't considering labor or time. This is just the fixed costs of the overhead of the infrastructure. And then in the Web 3 world, as I said, we have about a $400 buy-in. That typically will buy you a desktop computer with 32 gigabytes of RAM and 1 terabyte hard drive. That's enough to run the cache stack and have plenty of horsepower left over to do your own independent development work. And so members of the PSF have been buying those, programming them, and connecting them to our network. And as a result, we only have to have a few $4 circuit relays out there in cloud hosting. And so we've reduced our monthly cost from $50 to $4. And that represents a reduction of 92%. And what's great about this is not only if we had a centralized organization paying for everything, then that $400 computer would pay for itself in 8 months, and so that's compared to the $50. But what's even better than that is we've actually distributed this out among our community. So it's individuals who are intrinsically motivated, who are buying their own computers and maintaining them for themselves. So in some way, this comparison doesn't really make sense, because we've actually removed it from a centralized sort of thought process to a decentralized thought process. But if you wanted to compare this just within the context of a centralized company, these numbers make sense. So that's the presentation. That's how we lowered our infrastructure. And this is all sort of new-ish code. It's in production. It has been in production for months and has been very rock solid. but this is still a new area, and I encourage more entrepreneurs and JavaScript developers and cryptocurrency enthusiasts and people who love tokens to come and join us at the Permissionless Software Foundation, join our consortium, and help us push the edges of that spectrum out. So if you want to find out more, again, you can scan this QR code. It'll take you to a summary with links of all the stuff I covered in this presentation. But the main websites where you can find more information is cachestack.info, specifically about the Cache Stack, psfoundation.info to find out more about the Permissionless Software Foundation, fullstack.cache is the company that I manage, and you can hire me to build tech for you based on this software. And again, you can always find me on Twitter and Telegram at Chris Troutner. Thank you.